And that is easily the most controversial thing that I will ever say in the classroom this year. So thank you guys for not overreacting. Cool. All right, so here we go. Here's our warm-up. We're going to look at how to use these lovely calculators. I anticipate that at some point I will check these out to you. At home, I would encourage you to use the Desmos app on your phone. Desmos is awesome. It's so much better than these calculators. But these I'm not going to let you use Desmos on a test because obviously the internet is there. So here we go. First thing, when you turn on the calculator, there's an on button down here. Sweet. Turn it on. Now I'm going to reset mine so it's completely blank and there's nothing in there. So here we are. If you would like to know how to do that, because they have stuff set in your calculator, let's all reset them right now. Okay. Yep. We're going to go through it all. As we're looking at this, right off the bat, just a few basic things with the calculator. All the regular buttons are written big, right? Like, okay, what if I wanted this blue one? What if I wanted a letter here? Alpha. Here's the deal. If I ever pick up a calculator and I see profanity or hate speech or anything that shouldn't be written on your calculator because there's letters here, we're going to do this class with no calculators. Cool. I don't want to see any terrible things when I pick up the calculators. Sweet. All right, so to reset it, we are on right off the bat. We're going to hit second. Now, it should show that there's an up indicator here. Above plus on your calculator, what's written in blue? Memory. So hit second plus, and it gets us to memory. Now, you have two options when you're navigating through your calculator. If I'm going to go down to reset, I can use the direction, the D-pad here, and I can go down to 7. I can also just from the top go up, but we'll see we get a bunch more. Or what number is reset? I'm just going to hit the number 7. 7. So second, and then a plus sign for memory, and then I hit 7, and I want it to erase all RAM, so I can either hit the number 1 here, or I can hit enter. I use the numbers normally, 1, and then are we sure we want to reset it? What number should I hit? What would 1 give me? Yeah, I do want to reset it, so hit 2. Okay, does anybody have a different screen after we did that? Okay, King, did you miss a step along the way? What should you have done? You do have that screen. It says random clear. It says a little bit different, but we're on the same thing. Okay, so here's the cool thing. If any of these calculators have Blockman or anything like that, now they don't. Just throwing that out there. All right, so let's graph. I don't know how I'm stuck. Somebody help. How do I put in the graph of x squared on here? Oh, there's a y equals button in the very top left. Hit that bad boy. Now, we should all be at y1, I would assume, especially if we all reset. We're going to type it in. So couple options here, and there's some things about these calculators that I love. There are some things about this calculator that I hate. First is this lovely button right here. It says x, t, theta, that's a Greek letter, or n. If we want the variable x, there it is, x. It's this button right here. What if I want to make it squared? So there's two options. There's a squared button right here, x squared, kitty corner or diagonally from the number 7. Or you can use this lovely caret. That's how I refer to this.
Like completely bad.
Sheesh. That is unexpected, my bad. Okay, I'll use caret on mine. If I use the caret, it pushes me up into the exponent. I'm going to hit 2. Here's where if you elect to use a caret button, you need to be careful. If I wanted this to be the graph of x squared and then plus 1 afterward, if I hit plus 1, and you guys don't need to, I'm just talking about it, did my plus 1 go in the right spot? No. If you are using the caret button, be real careful. You have to hit 1 to the right on the D-pad to get out of it. Okay, so I'll go back. I just have x squared. I hit enter. What if I now want to see the graph? Oh, there's a graph button. Okay, let's graph it. Okay, your calculator will default to doing -10 to 10 and -10 to 10 every single time. That window will not always be the best for us. When we need to change it, we will. Okay, so here's a regular graph. It's a parabola, opens upward, it's happy, cool. If I want to be able to see what little changes might happen, I can keep the graph of x squared. I just went back into y equals, and I went down to y2. The next one that we were supposed to do was x minus 2 squared. So parentheses matter big time. I will add a left parenthesis, which is located above 8. We will just type in x minus 2, and here's one little weird thing. There are 2 minus buttons on your calculator, and I hate it, but it exists. This is the operation. This is how you subtract something. What does this one do? It's negative. Should we have x negative 2 or x minus 2? Minus. So here we go, x minus 2. I'll put parentheses. And then if it's a quadratic, I will normally use this x squared button right here. I now have x minus 2 squared. If you have anything other than these two things on your screen when you're typing these in, now would be the time to ask. Cool, cool. All right, we hit enter, and now I graph. It will show me the first one still. Here is the graph of x minus 2. Now, we're going to bounce back and forth between our notes in this. Absolutely. So, whoa. Whoa. So here I am. Now, hypothetically, let's say somebody typed in a, I don't know, they forgot the minus sign. Like, this will happen. I hit the delete button right here, but here's where these calculators can be a pain in the butt, and I don't remember exactly, so we're going to have to work with this. If I wanted to do x minus 2 now, if I start typing it, it just destroys everything that's there, right? You guys remember hating that about these calculators? Well, if only there were an insert button. Right here. Insert. Now, here's what I don't remember. If I insert when the 2 is highlighted on my screen, we're going to see if it goes up in front or behind. So if I hit second delete, and I do minus, it put it in front of it. I can insert stuff without having to rewrite the whole screen. Okay, Kennedy, are you caught up?
Yep.
All right, so now in our graph, here's the graph of x squared. Zoop. Here's x minus 2 squared. Zoop. What happened to it? It went 2 to the right. What if I did x minus 7 squared? Ooh, how about x plus 3? X plus 3. So 3 to the left. Now what you guys are starting to do is, without even having to use a language, you are taking the parent function x squared, and you're telling me that you can anticipate and predict what the transformation is going to look like. If you guys know that x squared is a parabola and you know that it moves left 2, how many of you guys think you can envision either on your page or in your brain that if you take this and you make it 2 steps in either direction, you can just make it like this now? Is that helpful in graphing and thinking about the graphs? Super helpful if you don't have to graph them every single time. Okay, we're going to change that second one. Let's look at our notes real quick. X minus 2 did what? Ooh, I love that word. Somebody used the word translate, and I love it. But we'll just hit it here. It moved, and translate is the better word. We'll define that probably tomorrow, realistically. To the what direction? Okay, I want everybody to internalize this, because this is the only weird one. Inside of our parentheses, if it's a minus whatever, it moves to the right. If it's a plus, it moved to which way? To the left. Okay, what did this one do? And if you haven't answered it yet, on your calculator, I want you to go into y2, and we're going to replace that x minus 2 squared. We're just going to replace it with a 3x squared. So I'm going to come down. There's a clear button right here. I'll just clear the whole screen, and I'm going to do 3x squared. And I want you guys to tell me, what did it change about the graph? It got narrower. I like that. Now, with quadratics specifically, there's some weird stuff that happens with them that we'll see. But here's my original x squared. Here's 3x squared. Did it indeed get thinner? Yeah, it got more narrow or thinner. So, thinner. Now, there is better language than this, but this is just kind of the intro. Okay. Do you guys remember talking about transformations of functions with Ms. Jarvis? I remember talking about it with Ms. Jarvis because when you get to exponential functions, they can get kind of wonky how you think about it. Here's what we're going to do. We're going to just barely get started on the intro today, but I want to make sure that you guys know where we're going. So it doesn't really matter if we have f of x is x squared or x cubed plus whatever. Like, I don't care what the function is. We have the same general rules the whole way through. So for our entire section, we've already named it. It's 1.2 transformations of functions. We're going to just look at what we're going to play around with over the next, tomorrow we'll finish it. So here's our big question. Like, at the end of the lesson, here's what I want you to be able to answer. Given a function, f of x. Now we could call it g of x or h of x. It doesn't matter what we call it initially. But if you give me a function f of x, Then, what changes if we use, and I'm going to let everybody catch up, and we're really just setting the intro for today. The homework took way longer than expected. Totally cool with it. Given a function, func is my shorthand for function. We're getting funky in here. Given a function that we call f of x, I want to know what changes if we use, and we're going to look at a big ugly expression, but it's not to scare you, it's just to give us a jumping in point tomorrow. Okay, I want us to consider a function instead that will say h of x, it's a new one, but it's just going to be some changes to f. And we'll clear all these up. So y'all ready for some real ugly stuff? Okay, we get a times f of. Okay, these ones, I'm going to use slightly different letters than your book because I keep it consistent throughout every chapter, but you'll see the same thing just with letters moved. Okay, we're going to have b in another little smaller set of parentheses nested inside. We'll write x minus c in there, plus k. I want to know by the end of this section, and you guys can start packing up because we are at the end of the day. Tomorrow, you will be able to tell me, what does A change? What does B change? What does C change? What does K change? And if we learn it now in general, the same thing will apply to every graph we do this year. Cool. All right, on the way out, please put your calculators back in the thing there. What's that app I said you should probably download? Desmos. Okay, as you're packing up, I'm going to talk at you, but you guys are welcome to go. The tech guy is already working on it. I think he took Eli's computer. Did he? Okay, on Google Classroom, if you look, hopefully this afternoon you will be able to access this. The very top of my page, there is a link to what's called Savas Materials. Open it, click this, log in with your Gmail. If it gets unblocked today, you will have access to the digital textbook. All right, CAL, see you later.